Okay, here is example 6 of finding the area of a regular polygon. In this case, we have another regular hexagon, but now we are given the radius being 6 meters. So what is the radius and how do we sketch it out? Well, the radius is the point that starts from the center of the circle, which is right here. And it's the distance that goes from the center to the circle. And in order to get to the circle, you technically have to go from the center to all of the vertices, or each of the vertices of the regular hexagon that is inscribed in this circle, because the vertices of this regular hexagon meet with their circle at its vertices. So this in the green here, the lines in the green here is the radius, and this is 6, 6, 6, 6, 6, right there. Now, because this is a regular hexagon, we know that this angle has to be the same as this one, which is the same as this one. So all angles of this regular hexagon has to be the same. Hence a singular marking that I'm writing right there. Now, we have to figure out all of the angles of each of these triangles inside this regular hexagon before we can even get started on using the formula of the area of the regular polygon here. Well, because this is a regular hexagon, it's going to be a little easier for us. So let's suppose we start at one point and we go all the way around. Well, every time we start at one point, we go all the way around. That's 360 degrees. But because we got one angle, 2, 3, 4, 5, and 6. And because this is a regular hexagon, we get to take the total degrees, which is 360, and divide it by the amount of such interior angles right here that we have, which is 6. So we get 360 divided by 6. We know the degree of each of these angles is going to be 60. Like that. Using the alternate interior angles theorem, if this angle right here is 60, then on the opposite side, on the other side of this transversal in the green, aka the radius, this angle here also has to be 60. If this angle is 60, then by the same alternate interior angles theorem, this angle here is also 60. If this is 60, this angle is 60, then this remaining angle here is also 60 degrees. And you keep going for all of the other angles that you saw. So like that. So all of these angles are 60 degrees. Now we can go ahead and get started on finding the apothem and then finding the perimeter. Now remember that the apothem is the distance, which is marked in the red here, from the center to one of the sides of this regular hexagon. And of course you can draw to this side, to this one, to this, and so on. And of course this apothem and the side that is approaching is going to intersect each other perpendicularly, so that's going to be the right angle right there. Now to figure out this apothem, we are going to need to use 30, 60, 90 triangle property. But before we do that, let me go ahead and denote each of the sides of this regular hexagon by the letter S, so that I can, do the math a little easy. So to find the apothem using the 30, 60, 90 triangle property, I'm just going to go ahead and select the bottom triangle, which is this one right here, and I'm going to select the left half right there. So the left half, pulling it to the side, so it looks something like this. Now this angle here, this angle is this one, 90. This angle here is 60, so it's this one. If this is 90, this is 60, this has to be 30 by the triangle angle sum theorem. So that's one reason. Another reason is because this angle here, this angle 60 degrees here, got bisected by the apothems. So 60 divided by 2, that's how we got 30 and 30. So that's where we got a 30 right here. So by the 30, 60, 90 triangle property, opposite to 30 degree, which is a short leg, is denoted by a variable, I call it x. Opposite to 60 is the apothem denoted by x times square root of 3. Opposite to 90 degrees is going to be the hypotenuse denoted by 2x. Like that. Well, recognize the fact that we already given the radius, which is the hypotenuse in the green, and the radius is 6. So that means this right here, we can set it equal to 6. And solve for x by dividing both sides by 2, we got x equals to 3. So x equals to 3 here, and this side equals to 3 times square root of 3. This right here, x equals 3. Remember that it's only half of the side or the base of this green triangle. Well, if it is half, if x equals 3 is only half of this entire base here, but this entire base denoted by the letter s, we get to go ahead and set this 3 equal to s divided by 2. And multiply both sides by 2 to solve for s. We know that it's going to be 6 meter equal to s, which is equal to the side of this regular hexagon. But because this hexagon is regular, we know all 6 sides are going to have the same value. So that means this is going to be 6 meters, 6 meters, 6 meters, and all the way around like that. Well, with all 6 sides being 6 meters, we know the perimeter is going to be the sum of all of those sides. Note that this right here is the apothem. So we have the apothem in place, and we have the perimeter 36 meters in place. So the area of this regular hexagon is going to be 1/2 multiplied by the apothem, which is 3 square root of 3, and multiplied by the perimeter, which we add all the sides together, is going to give us 36 meters. 36 divided by 2 is going to be 18. So we get 18 times 3 square root of 3. Well, this is going to give us 54 square root of 3 meters square. This is the value of the area of this regular hexagon.